So welcome you all, coming from all around the world to the University of Vigo. My name is Miguel Carbonell. I'm part of the QoPHI Lab. I am a social science guy. I don't know what I'm doing here with physics, mathematicians, and also engineers that are coming to Vigo to learn, right? First of all, from the organizational team, we like you to understand that we welcome you for you to enjoy this experience. So welcome to Spain, the freezing Spain. You thought there were going to be 40 degrees. No, this is Vigo, Galicia. The weather is amazing. So apart from enjoying, a hackathon is conceived for people to expand their creativity. Be creative. That's everything that we want from you. To be yourselves and to create something. Our colleagues will be explaining to you in a few minutes what we expect from you, but also apart from creativity and enjoying, there is also time to network. You are students close to be PhDs, also doing your masters. And the amazing thing of being in an institution such the University of Vigo is that you have the opportunity to network. One of the organizers is the most important Spanish company in the naval industry. So enjoy, but also network, because your future will be bright if you are in hands of the best companies in the world. And my notes. I'm an old-fashioned guy. And also, a hackathon is conceived to compete. You will be divided in teams, and it's part of the deal. In order to become the best in the world, you need to compete to others. Do it on a smooth way, but do it, you know, it's healthy also to compete and to be where are your boundaries. And for no further delay, let me introduce you for the welcoming remarks, the Professor Borja González Valdés from the University of Vigo. He's the Deputy Director from the Engineering Telecommunication School of this institution. Borja?
Thank you very much. Well, first of all, welcome to the University of Vigo. I want to thank the organization for giving me the opportunity of giving you this introductory talk. I'm just here to show the support of the university and our school to this event. Since this is a hackathon and I know what I mean, I'm not gonna go into any deep presentation, but just I want to take this opportunity to show a little the things we do in our school, which somehow I think are relevant for this hackathon, and to show the studies we have in the School of Telecommunications Engineering, which is known as Teleco here. And it's gonna be like 6 minutes. Don't worry. First, I'd like to start with the study map. We have the full path from bachelor to master to PhD program. I believe that most of you are already in a bachelor degree or maybe in a master, so many of these things are gonna be known by you. But I just want to point out that basically we try to cover everything. So in terms of what we do, when I remember when I studied like 1,000 years ago, started to go to this school, and I say you said telecommunication, people thought about phones and maybe old-fashioned radios. Now we do that. We do antennas, we do phones, but also we do a lot of other things. So we work in a very multidisciplinary profile, and our students are able to work in electronics, networks, programming, signal processing, and systems. And in that sense, when our graduates finish, they go into basically any field related with technology. I know people working in everything that is here in most, like machine learning, big data, augmented reality, obviously networking, also in aeronautics, aerospace. Pretty much, if you finish this degree, you are ready for anything in technology. Basically, we are a university, so we prepare people for working, but we do also a lot of research, and I don't want to lose this opportunity to talk about we have like 11 or maybe 12 groups integrated in the Atlantic Center for Telecommunication Technologies. We do probably hundreds of projects every year with many companies, and we lead the company and the university in earnings. And again, the Atlantic Center, which is hosting this event, allows us to basically to group the groups to help further and to help collaboration lines between groups. We work with many companies in research, all of them and more. Obviously, Navantia, which is organizing this event, and many more. And we work in doing research and doing transfer. So the technology we develop in the university gets transferred to the companies, so they can exploit it. In terms of on collaboration, it's also very important for us the internship. In our degree, we have a very strong internship program where the students can go to these companies to work, and basically many of them stay in the company after they finish the degree, and they work there for many years. And again, in many different fields, from software to electronics to cybersecurity, even in some I know some people that is working in the mechanical field after doing the telecommunications bachelor degree, and they are more or less fine. After the bachelor degree, we have a very strong master's program, which maybe some of you can join in the future, I hope. We have now 7 different masters. I'm not going to go into detail, but we have from telecommunication engineering to cybersecurity, IoT, extended reality, industrial mathematics, computer vision, and quantum information science and technologies. All of them are given by some of the best professionals in their field, and they are giving the graduate students further knowledge into these fields, which are the ones they are more interested in. And finally, probably what is more related with what we're doing here, we have a very strong PhD program. And when I was seeing the program of this hackathon, I was thinking it's like somehow a PhD program, like in 3 days, right? They give you a problem, and you have 3 days to solve it and present it. A PhD program is more or less the same thing. It's 4 years rather than 3 days, but usually you have to solve problems that are known, not that non-solved or are solved from a very non-optimal way. You have to work on them, and that's something we do in the university. We have a very strong PhD program where we teach researchers that are all over the world in the best places doing cutting-edge research. And finally, it's like 2 more minutes. I don't want to lose this opportunity to show something that maybe we don't show that often, or we don't brag about that often. That is our labs. We have excellent labs that we use both for teaching and research. We have the acoustics laboratory, the radioelectric chamber, which is my field, where I spend, when I can, a lot of time doing investigation in antennas and radar. We have the space lab, basically working in CubeSats and space-related technology. We have the aerospatial research group. This one is very cool. I really like it. It's the Clean Energy Ship project, which is basically making solar boats to compete in competitions, and it involves a lot of students. It's a really nice project. The Information Technology Group, which covers many things, but I think the more relevant probably is the 5G environment. And then we have this lab that is bringing us here today, together with Navantia, which is going to be presented further in the presentation. But it's also one of the most important of the school. That's pretty much it. I want again to thank the organization. Thank you for being here and for being part of this. And welcome to the University of Vigo. And I guess good luck in these 3 days. And that's all. Less than 10 minutes, right?
Professor Gonzalez. So it's about networking, connecting the future, and the future is here. I'm going to, with no further delay, to introduce your 2 hosts. First of all, Álvaro Aguirre from QoPHI LAB. Álvaro, a big applause for Álvaro. Come on, Álvaro, don't be shy. Here we go.
Oh, thank you.
Thank you, thank you. And now, Iago González from Monodon by Navantia. Iago, how you doing?
Hi guys, how are you?
I leave you in good hands. Enjoy.
Yes. Cool. Welcome to Vigo. My first message to you is enjoy, have fun in this event, and try to chill. I mean, the whole challenge is going to be a little bit complicated, maybe easy for some of you, but it's just a matter of enjoying and be yourselves and try to meet as many people as you can. And yeah, have fun here in Galicia. Well, first of all, where are you now? We're in Galicia, literally over there in a remote area I call Mordor. I mean, you already have seen that we have like a lot of clouds, even though in the rest of Spain it's like 40 degrees. But it's nice, I like it. It's like heaven, a little piece of heaven here. So yeah, we call it Galicia, short for California. I don't know why, but I think it's quite similar to it. We have pretty good food. I mean, I don't know if you have tried already the octopus, the tortilla, rasho, or like, I don't know. I can continue mentioning like a lot of things. They're pretty good. People, I mean, Galician people are amazing. They're super friendly, super familiar, and they will actually welcome you to their homes and stuff. Yeah, so you can always feel at home here. Well, the good weather, even though some of you may not like the cloudy days, for us it's actually pretty nice. Like last week it was 40 degrees. That was hell. I mean, I was staying at my house with ice cream. I was doing nothing because it was actually pretty impossible to go outside. So yeah, cloud. It's like cool, nice. We got mountains. I mean, here at the QoPHI, it's like remote area, pretty far away from everywhere else. I don't know if for some of you it has been hell to reach here, but the first time you actually try to arrive, it's actually pretty bad. But well, it's kind of a challenge. It's good. We also have the ocean. I mean, the Atlantic Ocean is nearby. We're pretty near Portugal, so that part of there, like during the winter, it's amazing. Even if you like surfing or those kind of water sports, is like a little piece of heaven. I mean, it's nice.
It's clear you love Galicia.
No, I don't. I mean, I like Estrella. That's most of it. But another thing I like is octopus. I mean, they're amazing. So why here and not in, I don't know, maybe San Francisco? I mean, I don't know if you have met the IPs from the group. His name is Francisco. That's why I'm doing this correlation. And also because, I mean, well, the Bay and the Bay. San Francisco is called for Silicon Valley. Here in Galicia, I don't know, we can come up with Gallium Valley, maybe? I don't know. Let's go for it. Also, we have the Golden Gate Bridge in San Francisco. In here we got Grande. I mean, it could be a cheap version, but actually you have to pay a lot if you want to travel from Pontevedra to Vigo. It's hell. An additional part would be the hills. I mean, in San Francisco, you got the trams, you gotta go up and down, up and down. Well, your butt actually grows like pretty much. In here, you also have it, but we got escalators. Thank you. Amazing, actually. An additional thing, I mean, I don't know if you have been to San Francisco, but actually in San Francisco, you got lobsters. In here, we have something similar, but it's even better. We have the bogavante, which is amazing. It's actually pretty much expensive, but it's nice. I've never eaten it, to be honest. I'm poor. But well, they told me it's nice, so I guess it's good. An additional part, the lights. I mean, I don't know if you have heard the news around the world, but Vigo, it's amazing. You got the spark in here. I mean, lights. That's why we call it photonics. But well, yeah. Not only that, because, well, in Galicia we got great areas like villages. That's Vigo actually. We got the theas and the beaches and stuff, like natural resorts, which actually are pretty much amazing. They're impossible to find a person around unless you come here in summer. That's horrible. You're gonna find people from all over the world. Netherlands, Germany, China, I guess, yes. And also Madrid, many people from Madrid. Sorry, Navantia. Well, you can come up like to this fortress here in Vigo. I don't know if you have been there this couple of days. Maybe we'll have time, maybe in the weekend. It's pretty nice to go there like during the sunset. You will see Vigo and yeah, that's it, not very much. You cannot do anything else in there, to be honest. But well, again, beaches. That's Samuel. I don't really like that one. There are many others that which are pretty like even better. But if you want to go party, go there. It's amazing. Well, yeah, paradise. I think there's a mistake on the letters, but it doesn't matter. Let's go for it. Cool. So welcome again. I'm Alvaro. I'm a researcher from QoPHI LAB and also an innovation manager at PIX Spain Competence Center. To be honest, Competence Center, that's a pretty hard thing to say. Because if I'm honest, I don't even know what I'm doing there. But I guess I'm in charge of the part in entrepreneurial and project development, let's say. How did I end up over there and, to be honest, over here? First, I studied the materials engineer at the UPM, and I went to Tongyi Tashbe in Shanghai for half a year. Then I went and did a Master in Science and Engineer at the University of Twente. Because I got tired of clouds, I came here to Galicia, which, similar. I have like 5 years of experience in integrated photonics and nanofabrication, so yeah, I'm a freak. I like nano stuff, things that you don't even see, but you have to imagine, so yeah, imagination is one of my key points, let's say. I'm a product developer. I like entrepreneuring, like startups development is actually pretty cool. It's horrible at the same time because you're fighting with all of the, I don't know, things and problems that you may actually have in a real company, but you're on your own. At the same time, well, I'm really passionate about sports, surf, as I mentioned before. I mean, I love it. Here in winter, it's amazing. I've broken many bones. I never went to a doctor, which is actually a pain. My colleagues over there, they already know, like I always like go to the lab and go like, oh my God, I've broken a foot, but I never went to the hospital. That's a bad thing to do. After a while, you cannot move it quite right. And it hurts when it gets cold or it hurts when it gets warm. So yeah, it's a pain. I do skate also. And I do also paddle. I don't know if you have heard of it, but it's kind of tennis, but in a small range. You don't really have to run. That's why I like it. Well, let's go for it. We are QoPHI. What are we doing there? Well, we study optical communications and effects on photons. We try to develop optical chips, LiDAR, and many other things for many other companies. Basically, we do research, develop, and we connect with people. I mean, photonics is a really small world, so it's a matter of cooperation and actually coordinating different projects with different kind of companies and universities and institutions. Because once you study this, you realize that you have no freaking clue what you're doing. Like literally, I have to like 24/7 because I don't know what it's even a photon. I go like, okay, that's a pack of energy, but what is it? A wave? A particle? I don't know. Like it can be both. I don't understand it. But well, let's go from monodon.
Hey, thank you very much. So, hi guys. I'm so happy to meet you all. I've been sending you mails for like 2 months. I already know you. I know your names, your past, your history, everything about you. No, it's a joke. What's Monodon? Monodon is part of Navantia, okay? Navantia, as Miguel said, is one of the biggest shipbuildings in the world and is the biggest one in Spain. And Monodon is the research and development area of the company. What we do is we focus on deep tech technologies, technologies that have the potential to change the world with a lot of dual uses, and technologies that we need to research in order to create products with them, okay? So we have a lot of interest, but nowadays we're working in 4 lines of research. First, autonomous as an able company, we have a desire to create underwater drones that can help us in any kind of missions, scientific missions, animal vigilation missions, and for sure, protection missions for critical infrastructure under the sea, and also surveillance or even underwater mapping. Developing an underwater drone is kind of simple. There's a lot of them, but we want to develop the next generation of underwater drones. So we're testing a lot of technologies in order to create different components to have a new generation of drones. You have information in the website, and we work for this with universities along Spain and Europe, and also with universities in Australia, Tasmania, and the United States. It's one of our biggest projects. Second, we have the optical communication line. Our aim is to create, and this is everything everything about the Pulse, it's connected with this, is to create a possibility to have underwater communications from drone to drone and also ship-to-ship communications. You can see all the projects that we're working on. They're mainly with the QoPHI LAB. Nanotechnology, thinking on the next generation of materials that could help these drones or new products on our ships to be capable of new things. We're testing a lot of different things coming from the biological side to the more technical material side. And least for not last, the quantum side. Here we're not thinking on quantum computation, we're thinking on quantum applications. We're thinking on, okay, how we can use the knowledge that we have from quantum to create new products that will be helpful in different environments or also in cryptography. And we have different lines here, and we're working with different university groups along Europe, as I said before. What that mean? At the end, what we do basically is we have ideas on amazing products that we can create. We need scientific and great talent to help us build this product. So what we do is collaborate with base researchers, base university, or research groups, and try to help them in their first steps, developing the knowledge, and then create the first product jointly. We want to create a better future for all, and that's what we do. You can see a lot of information in the web, so I encourage you to simply go to monodon.es or monodon.com, and you have all the information there. I think it's enough. Alvaro, can we present the chair that we have together?
The chair, yeah, sure. So yeah, as Iago mentioned, we're currently trying to develop, well, a chair, optical communication system underwater, of course. The main objective is to establish, well, a direct line of sight. That means like, well, we want to connect two different points with light instead of using sonar. At the same time, there are some issues underwater. So it's like, okay, you don't know where the thing is going. You don't know if there's a drone in front of you, or it's like on the other direction, like you could be even upside down and you don't even realize it. So that's the known line of sight. So you gotta find the objective. So that's the second objective, to try and connect two different points. So yeah, that's the main.
Yeah, this may seem simple for you. It's not. There's not a lot of people researching on this, and we think this is a great opportunity to create a new generation products as well. Yeah.
That is true, It's pretty hard, it's horrible. And that laser over there, that actually can get you blind in a second. So yeah, you gotta be really careful. So well, PULSE Hackathon, cool. Welcome here. What is the main goals of this hackathon or project or competition? First of all, we want to do a project launch. We want you to develop something that actually doesn't exist, or maybe it does. Who knows? You gotta find it out. First, you need to focus your time on the problem solving, trying to figure out what could be the issues here, and also try to create a pitch to actually defend your solution to the jury in this case. That's going to be the main objective. Of course, you want to learn from experts. We got like a bunch of mentors over here, which they have like really good idea of what is happening here. They know a lot of photonics. They can help you out anytime, no problem. Also, prepare the team for success. So you're gonna need to cooperate with different people from different backgrounds. You may not know what they know, and maybe they even don't know what they know. It doesn't matter. You'll figure it out. So yeah, the main objective, like, cooperate, support each other, and try to solve it. Or at least, yeah, try. That's the best thing you can actually do. Yeah, make good, lasting relationships. Yeah, I mean, basically, in most hackathons, you actually make really good friends, and you actually, in the end, you have fun, even though you don't sleep much if you actually take it seriously. But yeah, I don't recommend that. It's better to have a good night's sleep. So yeah, the calendar is basically 3 days, well, actually 2 days and a half, let's say. We're on the first day, the welcoming stuff, technical support, whatever, blah, 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 lunch, that's the best part, and the teamwork. We continue to the second day. That is mainly like continuing doing the project and then trying to develop the pitch, because that's the thing you're gonna actually give out to the juries as an additional part to the resolution that you have. You want to actually defend your solution. And the day 3 where you actually, well, defend it to the people over here. So yeah, winners. Oh my God, that's fuck.
Only one moment, Alvaro.
Sure.
The university closes at 8 every day, okay? But you can do whatever you want. Not in the university because it's closed. But if you want to continue in a bar, in a house, in a hotel, you're more than welcome. But you're not supposed to because the university is closing at 8, okay? So simply for you to know.
It's a.
No, the university closed at 8.
So yeah, this is let's say a free event. You can do whatever. So basically, you will have support from the mentors. But if you want to grab some beers in a bar and try to solve it in a bar, it's no problem. And also, yes, he mentioned, yeah, closes at 8, so that's a big issue for us. But that's it. You can manage. Also, even though it's a little bit mixed up, PowerPoint problems, you know that. Well, we got 4 different prices. Thank you. Oh my God. Yeah, my brain just went like mush. First one, it's divided like a group, so that's like $500 per person. That's a lot. Second, 200. The creativity one is gonna be more like, okay, if you develop something that is out of our mind, like something that we could actually think about it, like what the heck, that could be a creativity one. Or yeah, I don't know, like something cool. And the pitch is individual. That's the person who actually presents here. If they actually defend it in a way that is super nice and cool, not like me, I'm actually like sweating over here and doing bad. Yeah, you get a win. Like, it's nice. So yeah, challenge. That's the most important part. Even though the last part you actually don't see it, but it's additional, so it doesn't matter. That's actually the part which we don't actually think you're gonna actually manage to do, because it's impossible. You gotta do a bunch of things. So first of all, let's go to the point. We want you to develop an approach to model an underwater optical comms. So between an optical transceiver and a receiver. So let's say you take a laser, you point it out, and you want to detect it. Cool. How do we do that? First, you search in internet. Well, you got a lot of tools here, like AI. Easy, right? Nah. You gotta search for a channel model. That's gonna be the easiest task. Because if you want to develop it, that is horrible. But if you have the brains, go ahead. I mean, that's gonna be epic. So yeah. Try to find a channel model where you can actually simulate, well, not simulate, let's say measure or trying to optimize a point-to-point optical link. You want to select the type of water, what is clear, oceanic, harbor, surface. I mean, there are like a lot of parameters. The more you take, the better, because it's going to be more complete. But of course, if you cannot reach even one, that is going to be bad, because it's better to have something simple that does work than something that is overcomplicated and doesn't. Select the system approach. It could be free space, could be cheap, could be something else. Nobody knows. I mean, to be honest, free space is the easiest. You select a laser, you select a receiver, and you actually optimize.
Let them decide.
Okay, cool. Yeah. That's gonna be good idea. You want to simulate the link behavior, so just to check different wavelengths to see how actually they work underwater. Water is kind of complicated. It's similar than air, but it's denser. I mean, yeah, it's water. So yeah, to actually point it out with a laser, I mean, if you have the time, you can buy a laser, you go into the water, put the laser inside the bag, because if you put it underwater, like, it will not work. And you will turn it on. You will see what happens. If you see it like in live, and you try to point out from one side of the beach to another, you will see that there are some issues over there. Just to give you a hint. Of course, we want you to estimate a performance metrics. Let's say to check out what is going to be the maximum length. Again, don't simulate it. don't create everything from scratch. Try to look in internet with a channel model.
Okay, there's any question here? Because I have a lot, but I don't know if you have a lot of questions. It's a moment. Hands up, and I will give you the microphone. Don't be shy.
You will ask ChatGPT, I know.
No, this guy's like amazingly clever, okay?
I have one question.
Sure.
So basically, we do everything, like we simulate everything. We don't actually build nothing. Like we don't need to build a model, like a simple small model or something like that.
If you can, you may do it.
Like, will there be tools provided for us?
The tools is going to be Python.
Okay,
Yeah, that's simulation.
I can answer this. Working with this kind of lasers, laser technology, it's a little bit dangerous for your side.
Oh, yeah, yep.
So the thing is that doing that kind of activity, it's not possible with the insurance situation that we have. That's why we're doing a simulation.
Okay.
Yes, as I mentioned before, the laser that we have in the laboratory, that is actually, let's say, it's pretty basic. We didn't even buy like an industrial one. Just a small scattering point, just like putting the laser and looking at the reflection, you get blind. So that's the level of, dangerous stuff. That's why we're doing simulations. It would be epic to do it like in live, but yeah, I mean, we're really concerned about your site.
But maybe you can ask Alvaro to show you the facilities. I don't know if this is possible, the lab.
Sure, I think so, yeah. I mean, we got the keys, we got the people, we got the place, we are nearby, so you can see it. That is no problem. About the selective type of water, I mean, I don't know if you have seen the courses that we posted in the website. There are some different effects happening in different materials, even though we cannot see it because PowerPoint issues. We got water absorption, so because of the molecules and the material properties that you actually have inside the water, even like in the air, there's absorption. There's an additional one, which would be attenuation, which actually, I mean, I got mistaken, that's the same one. And you got a scattering. So yeah, to simulate the whole thing, you will have to do some sort of like Monte Carlo, because yeah, it's probability. So if you can manage to do it, that would be cool, but it's extremely hard. So yeah, competition milestones. First of all, think about the problem. Go for the solution, present the result, and then do a pitch. Simple, right? 4 tasks. First of all, tackling the problem. Like, okay, what is the problem here? I don't know if you know what is the problem in the system. If anybody can answer. No hints? Go.
The propagation of light through the water.
Yeah, I mean, because water is a pain in the ass, let's say. It's dynamic, it flows, it moves. Let's say when you point from one side to another, the water is going to go like this. If you want to solve it in a way that sonar does, sound has to push the water because it's sound. It's a sound wave. It has to move the material to actually propagate across the medium. In water, it's funny because it's denser. It moves. It will actually distort the sonar. You want to implement light. But at the same time, light actually behaves super weird when there are some currents. If you apply heat, if there is some sort of, let's say, particle in the middle, I mean, in 10 meters, there may be nothing, but in like 1 kilometer, you can find like a small fish, which you may kill. It's not going to happen. I mean, it's pretty hard. But yeah, I mean, it's dynamic. You have a lot of things in there which you have to actually try to figure it out. I'm not going to mention all of them, but yeah, the more you actually take into account, the better it's going to be in the future in terms of solving the problem. Then you want to find a solution for it. Like, okay, cool. My solution is this maybe? I don't know. Like, for example, in the terms of sonar, you got a problem of it's going to be a 3D impulse. And also because you have to move the water, like you have to push it, and it's like a pain in the ass. With light, it doesn't happen. So you solve that problem. But another problems may happen. So you have to go back again and try to solve it again. And so, again, you want to strive for a result. You want to have a result in the future and try to figure it out if it works. In this case, with a simulation, all the model channel with the results. So yeah.
You want me to?
Sure, if you can, doesn't matter.
So the main idea with the storytelling thing is that it will be simpler for you if you have an idea on where to make your solution work. So we have created the concept of an underwater robotic swarm that needs to cooperate in a really fast way. Imagine having, I don't know, 25 drones that are mapping an area and trying to, I don't know, identify a number of fish or a movement of a number of fish in real time. They need to communicate really fast, and they cannot use sonar or other sound technologies because that could disturb the fish. So we decided to use laser, green laser, really fast pulses, almost invisible for them. And if we have that ability, the light is faster and it transmits a lot of information. If you have this idea of the pulse, the drones, you can for sure create. These are not existing drones. These are created by an art director, the IA director. You can think whatever. The main idea is that you have a concept that could work with these drones. And if you know something about drones, they're basically, even they can have, they're being built for specific missions, like for example, an explorer or a heavy lift class, or they can be modularity, and they can be having different components for different missions. You can use this information for your ideas or whatever. You're free to do what you like the most, but this is an idea. I don't know.
Yeah. So just take into account also the size of the swarm that you want to actually do. I mean, this is for storytelling, but at the same time for reality check. Also check for commercial. I mean, I forgot to mention, but commercially available products. Don't invent nothing that doesn't exist. I mean, you can also say that let's go for a laser that goes like 100 kilowatts. It's like, okay, can you make it? How much power do you need to actually make it possible? Like, does it fit in the drone that type that you have selected? Try to be realistic in those terms. So yeah, that's the storytelling part, and also reality check. As for the pitch, first of all, crafting your pitch. Follow a clear and concise structure, tell a story, try to make it, I don't know, funny or memorable, something that actually people can actually remember in the future. Of course, you need to be data-driven. Means that the stat that you want to present has to be real and true. Don't invent anything. So AI is a great tool, but double check. Because AI can actually make a lot of mistakes. I try to give it like a bunch of things, and you know, most of the times you go like, okay, you're wrong, you need to redo this. Like, okay, you're right, that is true, you're right, I'm wrong, let me fix it, and it does it again. It's a problem. But well, be data-driven. Articulate a clear value proposition. So let's make it a good presentation where actually you can actually explain everything, and demonstrate it with enthusiasm and confidence, and of course, have fun. I mean, that's the main point. We're here just to enjoy and to meet people, and of course have lunch. That's the most important part. The requirements is one person only presents, not two, not three, not four, just one. And it's gonna be a 15-minute pitch. Kind of short, but at the same time long. It depends on the amount of things that you have done. The jury will actually assess you on the terms of the pitch, will actually ask you questions in the end to see if you actually know the stuff that you have presented. And well, the slides must be presented or handed in by the 10th at 10 a.m., sorry. No exceptions. We will talk it out during the event, so you can give it out to us and to any of the mentors here, and no problems, no rush. The evaluation, that's important. Evaluation criteria, wow. So yeah, model physical preciseness. It has to be true, everything has to be real, and it cannot be fake. The quality of the simulation and interface. I mean, if you make something that kind of works, it's true, it's not actually pretty 100% complete, but it actually gives like a pretty cool interface, that's a plus. I mean, that's good, that's good. I will give you a point. The analysis and technical justification means that, okay, it could be true, but can you justify it as actually true? Or actually, do you actually understand what you're doing? Or you're just like literally copy and pasting everything and not understanding what you're doing in your life, like me every single day. So yeah, try to figure it out. Again, innovation, try to be creative, try to find something new, something different, something that maybe doesn't exist. I mean, you're gonna be competing. There are many institutes who actually have been trying to develop this technology for many, many years. It's a big problem. So maybe think outside the box. Try to figure something new. And the clarity of documentation. So if you make a clear and concise documents which you hand in, that is gonna be good. It's gonna be a plus because it will help us out to see if it's actually true or not. Again, your mentors, we are over here. We are a bunch of people. Most of us is from QoPHI Lab. Me, David, Sara, and Omar, for example. And again, Desiree, 2 people from Spark, which are like over there. Yeah, Nelson and Raul, and Javier Fraile, which currently is not here. He's going to be around. He's a tenured professor. He's going to be a little bit busy, but if you have any doubts, we can reach out to him, no problem. The jury, again, most of us, and another guy which currently it's in a concert, so he's not here. He will come back on Friday, and he's going to be your jury. He's a senior photonics engineer. He just recently came here to Vigo because Vigo it's amazing. He was in the Netherlands, but of course everybody from the Netherlands wants to come back here because Netherlands, traumatic experience. And again, well, 4 tips to make the most of the hackathon, whatever. So, first of all, find your group's rhythm. Try to meet each other. Create a group meeting. Try to understand who does what in your team. Try to assign like different roles like UI, UX designer, product developer, project manager, whatever. Try to be concise and organized. Each member should have like your own task, of course. Stay flexible and work with agility. I mean, you may need to find or trying to fix some things that on the spot, or maybe change everything from one day to another. Again, time is essential. Time is critical. Be flexible, dynamic, and try to change everything to accomplish the milestones. Tame the chaos again, because you never know what's going to happen. Maybe you go like for an idea, and at the end it doesn't work. You may have the time to actually fix it out. That's up to you. Yeah, flexibility is key. Network and learn from others. I mean, people from around the world. Some of you are from Vigo, some others are from Almeria, Luxembourg, I think, and I'm missing a bunch of people. Like there are like a bunch of.
The thing is that we have people from a lot of places, but as you notice in the WhatsApp group, we have some last-minute rehearsal of people who joined the hackathon last days, so that's why.
Summertime. So yeah, people from around the world, try to meet them, try to learn from each other, and you may never know if you're going to work with them in the future, which is actually pretty good in the end. Like you realize after 7 years, like I met you somewhere, and yeah, it was in a hackathon maybe, or somewhere else in a bar. And of course, have fun, take breaks, and enjoy well, Galicia actually. Questions? You have, well.
You can also ask later on if you don't feel like doing it right now.
We also have the staff members. If there's any doubt in terms of outside the technical support, we can actually reach out to them. Huh? During the coffee. That is Javier Fraile. Woo!
Okay.
What a good welcome. So yeah, getting started. First of all, try to meet yourself, like try to present yourself, name, city, stuff, like try to see your background, your interests to every single person in your group. Do a brainstorm session so you actually tackle the problem and try to figure out a way to solve it in the end. You don't need to solve the entire problem. Just focus on simple tasks and then go further and beyond. If you can actually reach out, there is no limit on the handing. If you can actually make something that it wasn't posted out in here, but it increases the credibility and the functionality of the tool, that is going to be a plus. It will be fantastic. And again, well, create a working methodology, like take tasks, roles, and stuff, so you can actually keep track of time and people. And that's it. Well, join the WhatsApp group if you haven't joined. I guess all of you have, so check, no problem. And the Wi-Fi network, Eduroam, which I guess every one of you can actually join if you're part of any university in the world. Yeah, I think that's it. I don't know if there's anything else. No, yeah, groups. Maybe there's some modification in here because there are some people missing, but yeah. And yeah, I need to fix that one.
So there's a little bit. Can you fix it in the computer so they can see the names, because it's like.
Yes, I know. I will have to connect my computer. No
I think
problem.
the simplest thing is that you get up and reunite by teams. Maybe group 1 in that corner, group 2 in that corner, group 3 in that corner, and group 4 in front of the desk. Okay.
And 5.
And 5 on the cameras. Okay. Thank you very much.